Okay, so we are going to learn 1-1. So there's the title of your lesson, 1-1 coordinate plane. A lot of this should be review, hopefully, with a couple of minor exceptions. And if I'm in your way, just wave at me and I'll move out of your way. There's so many of you in here, it's hard for me not to be in your way. All right. So there's your coordinate plane, right? You should have seen that in pre-algebra, 7th grade, 8th grade, 9th grade. Your x-axis is your horizontal. Your y-axis is your vertical, so make sure that you know which ones of those are the right ones. So those are your axes. And then we name our quadrants. This is where you do get messed up on. The very first quadrant you ever worked in was quadrant 1. And note that it is labeled with a Roman numeral 1. You cannot label it with a number 1. If you do, I'll mark you off because it's just not proper form. And then this is your positive quadrant. It's all made up of positive numbers. It's the very first numbers you ever learned. You didn't learn negatives before you learned positives. So that's where you first plotted points in. What would be quadrant 2? Would it be this one on the lower right, or would it be this one on the upper left? Upper left. Very good. So there's your quadrant 2, 3, and 4. So use your Roman numerals. And you can abbreviate quadrant with Q. So as I noted before, quadrant 1 is your positive quadrant because it is bordered by positives and positives. What's a positive times a positive? Positive. Quadrant 2 is a negative quadrant. Look at what borders it. Aren't these negative numbers on the left? Positive numbers up here. What's a negative times a positive? A negative. So what's the sign of quadrant 3? What's it bordered by? Negative, and these are negatives down here, right? So what's a negative times a negative? It's a positive quadrant. And think about this. What if I had a line? Here's my nose picker. What if I had a line? And my line, no matter what quadrant it might be in, it's in both quadrants 1, 3, and 2. But look at what the ends of this line are. Aren't the ends in quadrants 1 and 3? Isn't this a positively sloped line? Well, that's why the positive quadrants are diagonal to each other, because that's how we end up with our positively sloped line. If I have a line going in this direction, it's a negatively sloped line. This side is in the negative quadrant, so what do you think quadrant 4 is going to be? Negative, and look at what it's bordered by. Positives and negatives. What's a positive times a negative? Negative. So those are the signs of your quadrants. That's your most important point right there is your origin, and that's 0, 0. It's called the origin because it's the point of origination for every ordered pair that you plot. And by the way, if you can't see from where you're at, just move either up front down here or anywhere closer where there's no open seat. So here's just an example of an ordered pair. So you have two numbers in your ordered pair. What value is this? The -3. Is it your x value or your y value? It's your x value, and so the 4 must be your y value. They go alphabetically, don't they? X and then y. And then from the origin, if I were to plot -3, 4, if this is telling you to go -3 and it's your x value, it's saying go -3 the x direction. Well, your x only goes left and right. Your y only goes up and down. So a negative means you go up, down, left, to right. This is x. X only goes right and left, so you do go left. And then the 4, your y, do we go up or down? Positives are up. So you go left 3 and up 4. And that's where it would be plotted. Give or take a little smidgy out of the way. and you would label that point. So oftentimes points are labeled with capital letters, like A, B, C, or whatever. So you'd name that point with that capital letter, or you'd name it with -3, 4. Questions about the coordinate plane? Okay, hopefully that's all review. So write down example 1 and the entire problem, and make yourself a little XY grid. The air conditioning is barely working today. So sorry. So what I want you to do once you write down the problem is I do want you to plot Q, R, S, and T. And do connect them. You're not always going to connect your points. A lot of you are used to doing that, but in this case I do want you to connect them. And I want you to find the perimeter in the area of that figure. It's going to be a familiar figure to you. And if you don't write down the original problem, your notes mean absolutely nothing to you. So you do have to write down the words that are up there as well. Why it's important that you have graph paper in this class. We do a lot of graphing. It's really difficult to graph on the plot your points. You should see a familiar shape coming up here. What shape is that? What is it? It's a rectangle. So connect your dots. I think I connected them. Yep. So make sure that you did plot them in the correct quadrants. Very first thing we have to do is find the perimeter. Raise your hand. How do you find the perimeter of a rectangle? Ashley? Is that perimeter or area? So what would you do for perimeter?
Add up all the sides.
There you go. So add up all your sides. So what's the length from R to S? Count the number of squares. What's the length? 3. And what's the length from S to T? Count the number of squares. 5. Okay. So to find the perimeter, Ash just said to add up all the sides. You can also do twice your length plus twice your width. So you could take this length of 3 and double it, giving you 6. And this length of 5 and double it, giving you 10. Either way gives you the same answer. Right? What do you get? 16. What are the units of measure? Well, we don't have any units up here, so it's just plain units. Is it units or is it units squared? Just units. Perimeter is something, it's one-dimensional. If you look around the room, if you look at where the wall touches the floor, can't you see the perimeter around the room, that line? What happens if I actually go and touch that line? Am I touching the perimeter or am I touching the wall on the floor? Let's look over here instead. What if I touch these two walls? or this line right here? Am I touching the two walls or am I touching a line? Where does one wall end and one wall begin? How wide is that line? It has no dimension to it. But we can see that there's a line there, can't we? So same thing with the perimeter. I can see the perimeter, but I really actually can't touch it. So seeing it is your first dimension. I can see it. The minute I can see it and touch it, like I can touch this tabletop. I can see the tabletop and I can touch it. It has area. That's 2 dimensions. So your perimeter only has 1 dimension. You can only see it. So 16 units. Now how are you going to find your area? Say it really loudly. Yep, multiply the length times the width. Or in this case, I put base times height. It's the same thing. So you've got 3 times 5, right? Which is 15, and what's the units? Units squared. So really what I wanted you to get out of this was A, do you remember how to plot points? B, do you remember simple perimeter and area of a rectangle, which also goes along with a square, right? And then what are the units raised to? Perimeter's first, area's second. We're not going to do example 2 in the textbook. Bless you. So as soon as we scroll through it, here we go. All right, so write down example 3. If you want to call it example 2, that's fine. So example 3 says find the coordinates of 5 points that lie on the graph of -4 plus x equals y. Then graph the corresponding points and draw the line representing -4 plus x equals y. Hopefully from algebra you remember that this is what kind of a graph. Does it have a curve to it, or is it a straight line? When your variables are raised to the first power, does it have a curve to it or a straight line? What happens when you have an x squared? That was really fun in the spring semester last year. You graphed quadratics, x squared plus 5x plus 10, let's say. What did it look like? You totally forgot in your second semester algebra. Do you remember what a parabola looks like? An upside down U or a right side up U? That's when you have an x squared. What happens if x and y are to the first power? Straight line. So this is linear. It's linear because x and y are the first power. It's linear because x and y are not in a denominator. And it's also linear because x and y are not being multiplied to each other. So those are your tests for linear. So as soon as you have it written down, we'll talk about what we're going to do. So in this section, if they want you to find coordinates that lie on that line, I want you to choose some negatives, some positives, and I always want you to choose 0. Typically, your x is going to be your independent variable. X is going to be the one that we put numbers in for. And y is your dependent variable. It's going to be the one that we get the number for. In other words, whatever we input for x is going to affect what we get for y. So what are some typical values that we'll choose for x? What's one? -2. Okay, -2. How do we go from there? -2, another negative, lower, -1. And then we want 0, right? And then what else for our positives? 1 and 2. So those are what I would suggest because they're small numbers. So I put up here, typically I will choose -2, -1, 0, 1, and 2 as values for x. Now that would change if there's a coefficient in front of x that's a fraction. If in front of x we have a fraction, let's say 1/2, the denominator of that fraction is 2. So I'm going to choose values for x that are divisible by 2. Because otherwise I end up with fractional answers and I don't want that. So You'll adjust that depending upon what the problem is. All right, so make a column. I don't think I plugged them in, well, we'll see. No, I did. Go backwards. Oops, okay. So make a T-chart, an XY T-chart. So yours is gonna look like this. X. You probably can't see that very well. Let's try green. So you're plugging in these values, -2, -1, 0, 1, and 2 for your X. And then you're plugging into this equation, -4 plus X equals Y. And you're gonna get a Y. So replace X with your two new values. So you've got -4 plus -2 equals, what do you got? What's -4 plus -2? -6. And then we've got -4 plus, this time we have a -1. What's -4 plus -1? -5. Then do it again, -4 plus, this time we're putting in 0. What's -4 plus 0, everybody? -4. That was everybody? You're still asleep today. Put in -4 plus, this time we're putting in 1. So you have a -4 and a 1. What do you get? -3. Do you see a pattern forming down here? As X is increasing by 1, what's happening to Y? It looks like it's decreasing, but they're negative numbers, aren't they? The lower the negative number, the less debt you're in, right? The less money you owe somebody, so you actually are increasing by 1 here. Plug in -2. What's -4 plus 2? And according to this pattern, we should get a -2 over here, and sure enough we do. So, your ordered pairs are -2, -6, -1, -5, 0, 4, -4, 1 and -3, and 2 and -2. Plot those points over there. They should form a straight line. If they don't, you did something wrong. So there's your 5 points, and then the directions say draw the line representing that. So you want to connect those with a straight line, and there it is. Make sure you have arrows on both ends of that line. Questions about that? What if you knew how to graph that using y equals mx plus b? Could you have done it that way? Let's talk about it. Y equals mx plus b. What does m represent? Slope. What's b? The y-intercept. So I'm going to rewrite this so it reads y equals mx plus b. So the y comes first, then the x, and it's a positive x. The 4 is negative, so minus 4. Where does this line cross the y-axis? Where is its y-intercept? -4. So couldn't I have plotted a point right here on the y-axis at -4? And then what's the slope? What's the coefficient in front of x? 1. So the slope is 1 over 1, or you can change both signs, -1 over -1. So if I stair step that slope, I go up 1 to the right 1, plot a point. That's one of my points that we just did. Up 1 to the right 1, plot a point. Or down 1, but to the left 1. Down 1 to the left 1. Could we have gotten the same 5 points that they were asking for without doing a table? Yes. Question. I can't hear you. What? The y-intercept. Where the graph crosses the y-axis. And that's because on the y-axis, the value of x is 0. So when we plug in 0 for x, we got -4. And if I plug in 0 for x here, x disappears and all I have left is y equals -4. So no matter what you have in front of x, if x is 0, you're going to be left with that constant that's being added or subtracted to it. So I don't care if you use a table, if it's a linear function. If it's not linear, in other words, if one of the variables is squared, or if they're multiplied together, or if you have a variable in the denominator, then you're going to have to use the table. But if it's linear like this, go ahead and use your skills of y equals mx plus b. Either way. All right. I just put on there, you can see that all 5 points lie on the line. Here's a question for you up at the top. Name the coordinates of one point not on the line. How many answers could you have to that question? An infinite number. So you write down something, an ordered pair of something that's not on the line. Now I wouldn't choose some crazy ordered pair that might end up, remember this line extends forever this way and forever that way. So I wouldn't be crazy about it and creative. Choose something you can physically see on here, like that would be over here, totally away from the line. Because you don't want to make a mistake and end up choosing a point that's actually on the line. And you can double check your point by plugging it into the equation and making sure that it doesn't work. So give me a point, any point that's not on the line. 0, -1. Would you all agree that that's not on the line? Okay, so let's plug that into here. If x is 0 and y is -1, what's 0 plus -4? -4. Does -4 equal -1? True or false? False. And so it does not satisfy the equation, therefore it is not on the line, and therefore we've answered that question. Any ordered pair that is on the line, and so let's just choose one that is. We'll choose that one, 0, -4. If I plug 0 in for x and -4 for y, because those are your x and y values, what's 0 plus -4? -4. This time does -4 equal -4, true or false? True. So if it's on the line, it satisfies that equation and makes it true. If it's not on the line, it doesn't satisfy that equation, it makes it false. That's the whole point of them asking you that question. So here comes your first definition. This is not on the flashcards that I put on my website. You need to add this to your list of flashcards. This is one of the questions on that pretest that I gave you on Friday, true? It says collinear. Co meaning with, linear meaning line. You need to write it down and write down the definition. So collinear means a set of all points that lie on the same line in the same plane. Can't just be on the same line, but they all have to be in the same plane. So both have to be true for it to be collinear. So what I would do for your definitions is put your definition on the front, or your word on the front, your definition on the back. And that way you ought to be able to read the word and then define it without looking at the definition, and vice versa. If you look at the definition, you ought to be able to identify what the actual word definition it is. So you want to read it forwards and backwards. So highlight that or star it so that you know that tonight you have to add that to your flashcards. And so the previous example to this, all 5 of those points are collinear. That one point that we chose, so if we had those 5 points, and if we included in that 0, -1, if we had those 6 points, would they be collinear? Yes or no? All 6 of those points. 5 of them are, but 1 is what? 1 is not. It just takes one rotten apple to ruin the bunch. So if I asked you about all 6 of those points, or all 6 points collinear, your answer would have to be no. But if I asked you about those 5 points from -2, -1, 0, 1, and 2 that we came up with, those 5 points are collinear. But the minute we add in that 1, 0, -1, it ruins it and they're no longer collinear because they're not on the same line. So non-collinear would mean a set of points that do not all lie on the same line. Non meaning not. And so again, this would be a definition that needs to be added to your flashcards. So you want to highlight and start as well, so that you remember to add that as well. And if you want to have your 3x5 index cards with you in class, and every time we have a definition, you can add those in so you don't have to do it when you get home, feel free to do that as well. Oh, that's it. Does anybody need that back again? Okay. All right, so